Bismillah Rahman Rahim. Dear students, we are studying about the neutron activation analysis and the applications of neutron activation analysis. Previously, we studied about what type of the fields where neutron activation analysis play their role. So we studied about the fact that direct gamma ray spectroscopy is most preferable process in neutron activation analysis in order to measure the elements in the sample material. And what type of flux is required, we also have studied. There is a detailed description of fluxes is given in chapter 2. Further, the analysis is preferably and most prominently is achieved in the field of archaeology, biology, chemical and metallurgical industries, criminology, crops and foods, geochemistry, petroleum industry, semiconductor, and space exploration. So these are the major fields where neutron activation analysis is being exercised. And we studied about the general procedure, pre-irradiation process. There is a irradiation process, and then there is a post-irradiation process. Pre-radiation process actually gives you sample uh, preparation, and the irradiation process is the bombardment of neutron, and the post-irradiation process is the separation and the analysis of gamma spectroscopies. So this is there is a cyclotron that is being used in different kind of processes of neutron activation analysis. So we come to the point again. The chemical and metallurgical industries are also addressed with the help of neutron activation analysis. So there are so many components, there are so many elements that have to use, that have to determine in different sample materials. And because the presence of these elements may uh, produce serious interferences, so in order to determine the amount of that particular type of elements in a particular elements as chemicals is most important. And so again, we come to the point bromine and iodine in organic halogen compound. So there are, bromine and iodine also a halogen compound, but in other halogen compounds, the presence of these two elements is possible. So in order to determine how much quantity of these two elements are also present, so definitely there is a elemental analysis procedure, and there are different elemental analysis procedure like that, atomic absorption spectroscopy and other ones. But I think because due to the very low limit of and very low amount of concentration of these elements in sample materials, these conventional instrument may produce some limit to identify. In this regard, neutron activation analysis play a very important role because it have ability to determine and analyze the component material at very low concentration level as well. So pre-irradiation treatment mean there is a dissolve of zero point 0.5 to 1 gram of the material in an appropriate solvent such as water, benzene or methyl alcohol, in which actually the component is going to be mixed and dissolved. So we can use that solvent, most probably water, benzene and methyl alcohol, and adjust the volume up to 5 ml. Transfer the solution into a polyethylene capsule 86 millimeter length and into 16 millimeter diameter, and 1 millimeter of wall thickness is sufficient. So this is the preparation of the target material in order to bombard with the neutrons. So then the step is irradiation. Irradiation mean in order to bombard the sample material, irradiate the capsule in a neutron howitzer containing typically a 50 milligram radium barium source. So there is a source of a neutron, that is a radium and barium, being used for the production of neutron. So this is a neutron howitzer. This is a neutron howitzer in which you can see that this is a irradiation port, and this is an aluminium source container, and this is a source storage, and like that as a superposition adjustment source. So in this regard, these are the irradiations part. And this is a paraffin. So this is a general setup in order to introduce, in order to bombard the neutrons, in order to bombard the sample material with the neutron. So this is called a neutron hyzer. Okay, post irradiation process. After irradiation, there is a post irradiation process that is allow 2.5 minutes for the sample transfer, then measure the induced activities on a well type gamma scintillation spectrometer. So it should be in your mind that there is a very uh, important thing is that after the bombardment of the sample material, you should have to transfer this material to the laboratory where actually there is a well type gamma counter is there. Well type just like a whole type well uh, having in a circular there is you can see that sodium iodide scintillation detector that actually receive the gamma radiation emitted from that sample material and then amplify it into the more electron and further analysis. So this is the post radiation process. Then determine the bromine and the iodine contents of the sample by comparison with irradiated standard sample material. So one thing is very important is that when actually you are going to determine some sort of element, the most preferably it is preferably it is practiced and exercised that you should have to use the standard material as well. You should know about the concentration of that material and impurity of that material that you are actually using as a standard. So in this regard, you would be able to compare the photo peaks of standard as well as your component material, and you would be able to get a result in a very safe and good way. Bromine and iodine were analyzed to be to an accuracy of 4% or better, with improvement possible by the use of higher neutron flux. So this is the important thing is that you can improve your efficiency by increasing the flux up to 4% and more and more. So this depending on the upper limit of the neutron flux being used for that type of for bromine and iodine. So it is again I will share with you that each element have a particular type of a lower and upper limit of a neutron flux. So you should try your best to adjust your neutron flux within the range of compatible for that particular type of element. So you can't go ahead beyond the limit. If you use the limit below the required limit and adjust the limit for that particular type of component, your result will be not good. But if you are using the neutron flux above the limit, it is possible that your material will not be activated, and or in other words, if the component, if the material is very in a large with high atomic masses, then it is most probably that your material may be fissile. It may be go to fission process. So your main target is to just activate. Just in order to by activation, you receive the gamma radiation from that particular type of sample material, and this analysis of this gamma radiation is very helpful for the determination of the element kind as well as the concentration. Okay, just 1 minute. Okay. These are different type of photo peaks that actually obtained through this process. Okay. These are the some other kind of analysis that are being done with the help of neutron activation analysis. That is determination of scandium, chromium, iron, cobalt, zinc. There are so many elements in aluminium sample. Aluminium is a very important element and play a hub of industry because there are so many activities, are so many products are there which are produced, which are prepared with the help of aluminium. So in this regard, there are so many elements may also be interfere in the strength of the aluminium. So it is very important in order to determine such type of elements, how many elements are there in the aluminium, and how much quantity of these elements are there in the aluminium. So if the quantity of these element is below the limit, it will not be harmful for the aluminium strength, as is you can say that the strength as well as the durability. But if it is more than the required limit, so it may harm the aluminium strength as well as may be corroded and may be deformed. So due to this reason, there is on to the complexity of this analysis. There are so many elements in there which actually going to be measured in an aluminium. So there are about 13 elements. A flow sheet of the author's chemical separation is reproduced. So this is a paper that was published in international journal, and our author has analyzed aluminium sample having a 13 element in it. And then he after that separated chemically. So after post irradiation, during the post irradiation process, he done very good job, as well as in pre irradiation process. So you can say here that there is so many elements, as there are about of 13 elements that actually may present, was also separated and then analyzed how much aluminum is there, and different quantities, different element quantity of different elements. So this is a very tricky and very headache work, because post irradiation process is also very you can say that complex, as shown in the flow sheet diagram. This scheme of analysis illustrates how various chemical separation techniques are combined to provide an efficient overall system for the analysis of many elements in one specimen using one irradiation. Gamma spectrometry is used for all measurements. So in all measurements, actually, after each step, when the author is going to separate one by one each element, and he uses to analyze each separated element with the help of gamma spectrometry. So it is very tricky. The other application is the element determination, gallium in aluminium. So it is another important factor. It might be possible that gallium is not possible in order to separate from a sample material in the presence of other, and so it was separately measured. Or in it is maybe possible that some author have used to measure only the gallium in aluminium, and he studied and he published these informations. Pre-irradiation process, weigh about 22 to 30 milligram of aluminium, as well as a suitable gallium standard, and seal it into polyethylene vials. Okay, then irradiated it with the help of some important flux. Most of the time, the authors and different type of chemists, as we studied previously, most of the time 10 raised to 12 neutron per centimeter square per second was used. However, time is varied. So here is about 30 to 40 minutes was used for the irradiation of a sample material with the help of 10 raised to 12 neutron per centimeter square. So this is irradiation process. After irradiation, allow at least 17 hours for the 2.58 hours manganese to decay. So it is again a very important factor that some type of there is some such type of interfering elements are also there, which you should have to wait to decay to zero. Or a minimum quantity that would not be able to detect. So in this would not be able to interfere. So in this regard, manganese is the sample is left for 17 hour for 2.58 hour manganese, because after 17 hours, 2.58 hours half-life of manganese. After each half-life, it decays to half of its initial quantity, and then it is completely decayed after 17 hours to the quantity that is not being harmful and not interfering. So this is the and one way to reduce the interferences of the component material as well of radiation system in radiation system, because it will no more give the radiation, and no more it will interfere in the gamma spectroscopy. So you would be able to analyze a particular type of element and its photopeaks using photometer. So then determine the gallium by measuring the 0.83 mega electron volt as photopeak from 14.3 hours gallium. So gallium actually the half-life of gallium is 14.3 and half-life of manganese is 2.58. If you actually analyze the sample material exactly after the irradiation process, so there would be a two photopeaks. One is of manganese and other of gallium. But if you left it for 17 hours, so all the manganese would be decayed into another element, and no more it will interfere in the spectrum photogram. So there is then after the spectrophotogram that you will get after 17 hours, that would be the only of gallium. So the gallium will show a 0.83 mega electron volt photopeak, that is along with by comparing with the standard, so it would be able to get a good result as well as accuracy in your process. Aluminium samples were found to contain from 0.02 to 0.1% of gallium. Okay, so these are the finding about the determination of gallium in aluminium. There is another important process. Copper is another important element, very important metal that is being used all over the world due to its conductivity power of electricity, as well as very least wastage of electricity. So, due to this reason, it is important as well how many elements may interfere in its strength and working. So, it would be very important to analyze, as well as if there is a high amount of different type of elements in it, that could be removed with some particular type of processes. So there is a determination of iron, titanium, nickel, copper, chromium, okay, molybdenum, vanadium, and like that, and copper. Okay, so this is okay. This is actually the measurement of different elements in a steel alloy. Okay. Uh, in the presence of different elements, manganese, determination of manganese in high alloy steel containing iron, titanium, nickel, cobalt, chromium, etc. Okay, so this is the important factor that again pre-irradiation process, that is the preparation of sample. The other is irradiation process. The 10-minute irradiation is being appropriate in the neutron flux 10 raised per 10 and neutron per centimeter square per second. So here is important, that is 10 raised per 10 neutron, not 10 raised per 12 neutron as previously we studied. So another process is the step one is the post irradiation treatment. Allow the sample to cool for about 4 hours, then place them in a well of a gamma scintillation counter. So this is a direct calculation, this is a direct measurement, because after cooling of the sample material, you are putting your sample material into the gamma well counter that will measure the gamma radiation count. All photo peaks of energy is about 1.5 mega electron volt. Take 1 minute counts every half hour for 2 hours, and also after half a day, 1 day, and 2 days. Extrapolate the long-lived background to the end of the irradiation or some other references time, and subtract from the gross counting data, obtaining the net counting rate from manganese. Calculate the manganese content from the result obtained with both sample materials. So these are the some you can say that a process that is being used for the determination of manganese in the alloy steel alloys. Other is the determination of gold in platinum. That is very important, because platinum is also very precious metal and gold is also the very precious metal. So there is another analysis how many gold is present in platinum. So you can use it by using pre-irradiation, irradiation, and post irradiation process. So although it is a very lengthy process, but it is the most important to determine the platinum in gold. Okay, so another important determination is the selenium in unspecified matrix. Selenium is a very excellent and very quite favorable, you can say that trace element, rare element, that is also being used in different medicines of human beings in order to strengthen the neuron system. So it is important to measure how much, how one thing is very important. If the selenium quantity is higher as than your prescribed or allowed limit, then it would be very harmful as well. So it should be used in within the limit in order to treat the nervous system and nervous diseases. And also it also strengthen the human body with the most to overcome the energy deficiency inside the body. So pre-irradiation treatment is being used for this treatment for the determination of a sample material by neutron activation analysis. It is the preparation, and then sealing of the matrix, and then it is irradiation. Irradiation is again 3 into 10 is per 11 neutron per centimeter square per second for 1 minute. So it is only 1 minute, you can say that irradiation process, that is very quick process. And definitely post irradiation treatment transfer the sample rapidly to a gamma scintillation spectrometer to observe the decay of the 0.162 mega electron photopeak from selenium. So it should be in your mind, selenium's half-life is 17.5 second, and its photopeak is of gamma photopeak appear at 0.162 mega electron volt. So as I have in previous lecture I discussed with you, as the radiation time is very small, so you should have to transfer your irradiated sample very quickly to the laboratory for measurement. You know, you don't wait for a long time in order to become it cool and then we will measure. No, because the thermal radiation time is very small, about in 1 minute. So definitely you should have to uh, transfer it very quickly and analyze with the help of a gamma counter. Plata decay occurs to separate selenium activity from that of longer half-life, such as thallium, stannous, and barium. So in this regard, so content of various materials range from less than 0.02 ppm for ammonium thiocyanide to 68 ppm for sulfur. So these are the determination of a selenium process in unspecified matrix. Other is the determination of a hafnium in zirconium. So this is gone again some sort of a matter determination of the element, and it is well practiced for you as well. You should study, I think. So there are another type of neutron activation analysis that is known as fast neutron activation analysis. So in fast neutron activation analysis, oxygen in various matrices you can determine with the help of fast neutron activation analysis. So again, we should have to take the route of three steps. One is pre-radiation, other is irradiation, and then post-irradiation. This is a very simple process. Weigh out the sample and standards and place each into a separate container of low oxygen contents. Polyethylene insert the container in a pneumatic transfer system and transport it to the irradiation position of a fast neutron generator. So it should be in your mind, dear students, because there is a pneumatic transfer system. Pneumatic transfer system mean the involvement of the machines, involvement of the instrumentary boards to transfer your sample material at the place of your target areas where neutron will be bombarded over the sample material. Because you know there is a fast neutron, and these are the most energetic neutron, and these neutrons are may be very harmful. So in these such type of sources where fast neutron actually produced, so at there should be a good system for the transfer of target material, for the transfer of sample material to that point where fast neutron may hit your target samples. because your thermal neutron are also being produced with from the fast neutron, but it is not at the place of fast neutron. After fast neutron, there is a mediator is being used in the form of water, paraffin, or cadmium extra that actually slow down the neutron and to get a particular type of flux as well as the velocity in order to convert a low energy neutron that may be that also act as a thermal neutron. So after that, you should have to irradiate the sample. Irradiate the container 10 to 30 seconds in a flux of 10 raised by 8 Newton per centimeter per second. Okay, then transfer it rapidly to a gamma scintillation spectrum photometer. It should be remind that there is a 10 raised per 8 neutron per centimeter per seconds. Okay, this is looking low number as compared to the thermal neutron, but it should be in your mind the energy of these neutron is very high as compared to the thermal neutron. So after this process, there is a post irradiation treatment that is count the combined and 6.13 and 7.12 mega electron photopeaks activity from nitrogen and calculate the oxygen content of the sample material. Okay, there is um, a note levels as low as 10 ppm have been determined with the help of this neutron activation analysis. So this is a very low level that is being used with the determined with the help of faster neutron activation analysis. The other thing is that the neutrons of 14 mega electron volt energy are produced by the deuteron bombardment of a titrated target, taking advantage of a resonance peak near 100 kilo electron volt. So there is another advantage here, that is a resonance peak may occur that exactly after a regular interval appears with a high uh, peak area. So that also give you information and good advantage to measure the exact amount of oxygen in the sample material. The reaction with oxygen is reaction with oxygen is oxygen to nitrogen. So determination of a nitrogen is the directly related to the determination of oxygen. So no interferences are encountered if the gamma rays below 6 mega electron volt are discriminated against. Okay. Other thing is that area that is being favored with the help of neutron activation analysis, that is criminology. So neutron activation analysis has in recent years gained some acceptance in criminology. Typical analysis include the establishment of the origin of human hair and the identification of gunpowder residues. Briefly, the origin of human hair is identified. So it is important in order to determine different type of elements and like that, human hairs and gunpowders like that. So it give a lot of information in order to reach a target component and to proceed the case of any type of criminal nature. So this is a procedure element determine antimony, barium, and copper in powder residue. So definitely irradiation process is being carried out, then radiation is carried out, and then post irradiation treatment is being carried out. So dear students, these three steps as I have studied a lot and again and again. So this is just typical processes, and all the component all the sample are treated in the same way, but there is only small changes in their post irradiation treatment, definitely especially for each type of component, but radiation and pre-radiation are both are the some more or less are similar processes. Cadmium in biopsy sample, as well as we can determine with the help of this analysis cadmium in biopsy sample mean if there is any tissue you remove which is actually being targeted with the help of any kind of material, so then you pick that sample tissue samples from the body, that is called biopsy sample. So this sample is being analyzed with the help of neutron activation analysis. As with pre-radiation treatment, mean you are seal the 2 to 15 milligram specimen of human kidney as well as a filter paper standard containing 5 to 10 microgram of cadmium and cadmium sulfate into the quartz ampules. Then you have to irradiate and it's 12 neutron per centimeter square per second, and 2 to 3 days irradiation is required. Okay, so this is neutron activation has been widely used in determination of trace element in meteorites and in rocks. So there is another important sector that is also favored with the help of neutron activation analysis, that is geochemistry. So there are so many different geological areas. So it is very important to determine what type of elements are there, what type of the concentration of each element in that earth is there. So it is also very important. Sometimes there is so many things that was being discovered under the earth crust, and old horses, old utensils, coins like that. So all these, and particularly because we are studying geochemistry, so what type of material actually the people living in that era was used in order to construct their homes, and what type of metals and things they actually being used in order to prepare such type of material that is belonging to the geochemistry. So one thing is very important, that is the element determination of different type of elements. So this is a potassium. You may also determine sodium, aluminium, scandium, and dysprosium in rocks. So again, pre-irradiation process, irradiation process, and post-irradiation process is there. However, I will weigh out 30 milligram of the dried and ground potassium acid thalate standard, and about 30 milligram of the similarly prepared rock material. Place the material on polyethylene planches having an approximate area of zero point 0.8 per centimeter square, and seal the blanket with the ethyl acetate polystyrene cement. Okay, irradiation and then carried out with the help of neutron thermal flux 6 minutes for 6 minutes, and thermal flux would be the 5 into 10 raised per 12 newton per centimeter square per second. So what actually you will do after the irradiation process? Let the irradiation material cool for about 30 hours. Then count the beta radiation using a end window proportional counter, and absorbers of about 700 to 2000 milligram per centimeter square thickness. So this is a thickness of absorber material that is being used for the analysis of beta irradiation process. And not here we they are using the gamma radiation process. It should be in your mind. So there is because if the window size thickness is very low, it may harm to the workers there. This procedure determines the 3.55 megaelectron volt beta ray of potassium, and permits subtractions of sodium gamma radiation. The difference in the counting rate between counts and with each absorber is the contribution from potassium. Okay, so definitely difference of these radiation spectra definitely due to the potassium of present in that element sample material. Correct the data for decay and calculate the potassium contents by comparison with the phthalate standard. Okay, this is different kinds of applications that are you can use, and this is not only with the potassium. You may also the similar process may use for the sodium, aluminum, scandium, etc. Okay. Petroleum industry is also another important industry where neutron activation analysis play a very important role, because in petroleum industry the determination of interfering element is very important, because the petroleum industry the most important fractions of petroleum is the gasoline that is being used in vehicles and diesels like that. So definitely it is very important to determine how many elemental interferences are there. If it is unchecked and leave it to the vehicles, then it may cause very harm to the engines of the vehicle. So this is very important, and very carefully you have to study how many quantities of different type of elements are there in the petroleum industry. So definitely one thing is important again here. You should have to again think about the three steps: pre-radiation, post-radiation, and irradiation process. Then you should know about the type of material, and you should know what type of sample material is prepared, how much sample material is prepared for particular type of sample irradiation process. So here we can see that pre-radiation treatment seal 3.5 ml of a crude oil into a polyethylene container. So very common thing is that all the sample material is packed in polyethylene container. However, it depends. In some cases, it is further sealed into the aluminium or quartz like that. So this is you should keep in your mind. And one thing is more important, that polyethylene is the most common, the common material that is used to wrap to seal the sample material. Again, the neutron flux is thermal flux, 5 into 10 per 11 newton per centimeter square per second is used for 10 minutes. And then it is checked for the gamma spectrometry for the vanadium peak that is appeared at 1.44 mega electron volt. So you should know about these most prominent element that are may interfere in different component, and what is the photo peak of that element, and what is the half-life of that one. So this is the most critical for you people. So it is to be noted that prompt gamma rays can be used to obtain carbon, oxygen, and carbon or hydrogen ratios, thus furnishing a measuring of the relative concentration of water and oil as well. So these are the different elements and their activated nuclide and gamma ray energy photo peaks that is analyzed in the petroleum industry. Okay, dear students, these are the applications of different in different sectors using the Newton activation analysis. So, inshallah, Newton activation analysis, one part of Newton activation analysis has now been finished, and we will dilution and analysis through dilution method we will study in next lecture. And any question if you have, you may share with me. I will justify all the aspects. Thank you very much for hearing me. Thank you. Allah Hafiz.